In here, we imagine that we have another tool. It's called manometer, or like a U-tube manometer. It's like a U. It's a tube like a U shape, and it's called like a manometer to just measure the pressure. And in this case, for the U-tube manometer, normally we have the liquid, and imagine that the flow is running for the any kind of like a liquid, for example, water. In the U-tube manometer, we normally have the mercury with the, like the density of the rho m. And in here, once you're just going to have, this is like the separation point, separation between the pressure at the pipe and mercury liquid that we have inside the manometer. And the difference of that separation, the difference of the level of the mercury higher than separation here is shown by, for example, HM, the depth of the like the difference. And at the top of the manometer is like the atmospheric area, like we have an atmospheric pressure, is like an open surface or free surface. So let's just see how we're just going to do that. So first of all, we're just going to draw a XX line at the lower surface of separation. So that's like a first step. And imagine that like the separation to the center of the pipeline is like the difference is like the Z. So if you're just going to do this one, so we have like two limbs here, left hand limb and right hand limb. For the left limb, we're just gonna like the pressure at point XX. So the pressure at this point is equal to the pressure of the column here up to this point, the center line of the pipe. So it's equal to rho GZ. So the pressure up to this point plus, this is not open to the surface or open to the atmosphere. So we're just gonna write the rho GZ plus P, the pressure at this point. And on the other side of the manometer, or in the right limb, we're just going to write the pressure from the points of XX or at the level of XX. So we're just going to write the pressure at the top of that with the density of the liquid, which is, in this case is the liquid is the mercury. Just pay attention on the left hand side. The density here is the water, so, or the liquid, let's say general, and we just wrote it here rho. But on the right hand or right limb, the only like the liquid that we have is the mercury. But on the left limb was pipe liquid. So we just like it denoted by rho. So on the right hand side, we're just gonna write rho m GHM. Okay, rho m is the density of the mercury, HM times G gravity acceleration. So you're just gonna write this one, and based on the fact that you learned the pressure at the same level, they are equal, so we can easily equate on the right hand side. By equating the right hand side, you can write rho GZ plus P is equal to rho MGM. If you rearrange the formula, P can be easily calculated, or the pressure at the point and center line of the pipe can be easily calculated by using rho MGHM minus rho GZ. Okay, so that's the simple calculation for to calculate P. So let's just go with one example. We have a U-tube manometer. The lower part of the U-tube of the manometer contains mercury with the density of the 13,600 kilograms per cubic meter. The pipe contains water. This pipe contains water with the density of the 1,000 kilograms per cubic meter. Determine the gauge pressure P. Okay, this point. Okay, that's the purpose of the manometer, is to calculate the gauge pressure P at the center of the pipe if the manometer readings are shown in the diagram. So imagine the manometer readings is like the 0.4 meters, okay? And the separation, the point of the separation between the water and the mercury has got a distance of the 0.5 meters lower than the center line of the pipe, okay? So that's like the fact. So first of all, the same rule, we just draw a XX line here, and once we're just going to write that sort of things, and we can calculate the pressure on the left limb and right limb. On the left limb, pressure at XX level is equal to rho GZ of this one. Z is like a 0.5 meter, but let's just write it here as a parameter. plus P, okay, because this is not open to the atmosphere at this point. Rho GZ plus P, okay. On the right hand side, we can easily write a rho M or rho GZ, but the rho is like the density of the mercury, like the rho M GHM, which is here. And equating these to the right hand side, you can just write rho GZ plus P is equal to rho M GHM. And by rearranging this one, P can be calculated. You need to just substitute the figures here. Rho M is like a 13,600, G is a 9.81, HM is like a 0.4 minus 1,000 rho of the water times 9.81 times 0.5, and the result is 48.5 thousand newtons per square meter. Just bear in mind the unit here is Newton per square meter, or you can use it like a kilonewtons per square meter or kilopascal. This is the example one and the YouTube manometer.